Hello, my name is Yohana Muhammad Abdurasul. I'm a student of Makere University. I'm here to present. I will present my project on fundamentals of artificial intelligence and its application to my previous project, which we talked about the use of acoustics to predict heart failure. So for this, we are going to see 9 modules. Each module is related to our project. So let us start. The first module, the module 1, they have the artificial intelligence, the story, trends, and feature. So for the AI story, AI began in the 1950s with Alan Turing's idea of machines that can think like humans. In the 1950s and 60s, AI used symbolic rules and expert systems. From the 1980s until now, machine learning allows AI to learn from data instead of following fixed rules. Now, deep learning and big data enable AI to solve complex tasks like recognizing heart sounds or images. Then you have the point B, which is the AI trends. The AI trends. Modern AI uses deep learning with multilayered neural networks, natural language processing, that is NLP, for chatbots and big data as its fuel. AI improves with more data, making accurate predictions, like analyzing patient data. These technologies are used in healthcare for medical diagnosis, in self-driving cars, and in smartphones. Then you have the AI feature. For the AI feature, the feature of AI aims for artificial general intelligence. AI can think like humans. Ethical governance is needed to ensure AI is fair, transparent, and protect privacy. AI will help solve big problems in healthcare, climate change, and food security. AI will collaborate with humans, enhancing our skills, not replacing them. Then you have the link with our project. As we said before, each module is related. We are going to see each module, the relation to our project for each module. So for this one here, according to our project reflects the shift from symbolic rules to data-driven deep learning. We use heart sound data to predict heart failure, moving beyond all rule-based systems. It uses logical mathematical intelligence to analyze patterns and linguistic intelligence to interpret heart sounds as a key of language. It is an example of weak AI designed for one task, helping doctors make better predictions. Then we have 2 diagrams here that explain more, just to analyze easier. Then you have the module 2, which is the introduction to problem solving in AI. The first one is problem solving in AI. So for problem solving in AI solves problems using 3 ideas. You have the state, operators, and the goal. For the state, which is the current situation, like heart sound data. Then we have the operators, which are actions that change the state, like analyzing the sound. Then the goal, which is what we want to achieve, like predicting heart failure. Then we have the point B, which is problem types. AI works best with well-defined problems, which have clear goals and rules. Classifying heart sounds is a well-defined problem because the goal is clear to decide if a sound means heart failure or not. Then you have the not well-defined problems like composing music. These ones don't have a clear answers. For well-defined problems, AI uses step-by-step algorithms to find solutions. Then we have the problem-solving step in point C of this module. So for the problem-solving steps, first, AI defines the problem in the initial state. For us, the raw heart sound data, then it identifies proprietors like machine learning algorithms to analyze the data. Finally, it defines the goal state, a clear prediction of heart failure risk. The big challenge is dealing with complex and noisy data to find the right solution. Then you have the link with our project again. In our project, predicting heart failure is formalized as a problem-solving task. The initial state is the hard sound data, the operator is the AI model, and the goal is a diagnosis. This uses logical mathematical intelligence and faces the frame problem, filtering out irrelevant noise to focus on important sound features. Then you have the module 3, which is problem solving by search. So for problem solving by search, AI uses search algorithms like deep first search, that is DFS, and breadth first search, which is BFS, to explore solutions. Uniform search like DFS and BFS doesn't use extra clues. Informed search like A uses heuristics to give the search smarter and faster. In our project, this is like searching for the best patterns in the hard sound. Then you have the informed search and search challenges. So for here, in point B, you have the informed search. For the informed search uses heuristics and smart guesses to find solution faster. The algorithm combines actual cost and estimated cost to the goal. In our project, heuristics could prioritize sound features linked to heart failure, making diagnosis quicker. This is like a doctor using experience to focus on likely disease first. Then you have the point C, which is search challenges. The main challenge in search is too many possibilities, which is slow things down. Heuristics help by reducing the search space. Clustering, grouping similar hard sounds simplifies the search. In our project, clustering helps the AI focus on relevant sound patterns for faster analysis. Then you are going to see the link to our project again with the module 3. Our project uses search to find the right diagnosis in hard sound data. We use clustering to group similar sounds, making patterns recognition faster. This uses spatial intelligence to navigate data patterns. The search process is a simulation of reasoning, not true understanding, as discussed in philosophy. Then you have the module 4, knowledge representation and reasoning. So for the knowledge representation and reasoning, the first point you have the point A, knowledge representation. So for the knowledge representation, AI uses knowledge representation to store information. Simple AI uses facts and rules, like according to our project, like hard sound equals murmur. This helps AI make decisions and solve problems. Then you have the point B, which is first order logic. First order logic uses variables and quantifiers to represent knowledge precisely. For example, if a patient has a murmur, then they have heart disease. This allows AI to reason in a general way, not just about specific cases. Then you have the challenges of representation. The challenges of representation, that is the point C. So, in the challenges of representation, not all knowledge can be captured in symbols, like a doctor's intuition. The solution is to combine symbolic rules with data-driven machine learning. Rules provide structure, while machine learning learns patterns that are hard to define with rules alone. Then we are going to point B, the last point for this module again. That is the link with the project. Our project uses knowledge learned from hard sound data. We can extract rules like those sounds lead to heart failure. This uses linguistic intelligence to express rules and interpersonal intelligence for reflection. It shows the limit of formal symbols. Some sounds nuances are too complex for simple rules. Then you have our module 5, with the inference in first order. The first point is the point A, inference in AI. Inference means deriving new facts from existing knowledge. The deduction guarantees true conclusions if the rules are fact or true, and fact are true. For example, if abnormal sound means risk and a person has an abnormal sound, then they are at risk. Then you have the point B, which is soundness and completeness. A sound inference system only gives true conclusion. A complete system can find all true conclusions. For hard sounds, a sound and complete system would correctly identify all memory and never mistake a healthy sound for disease. Then we have the inference challenges. For the inference challenges, real-world data is noisy and incomplete, make inference hard. The solution is to use clear rules and high-quality data. In our project, the AI must deduce risk from subtle sound patterns while ignoring noise. Then the last point, the point D, linked to the project. Our project infers heart failure risk from sound features. It classifies sound into facts and uses them to to infer diseases. This is a logical mathematics intelligence and aligns with the Chinese room argument. AI manipulates symbols without real understanding. That is why. Then we have the module 6, reasoning under uncertainty. The point A is the Bayesian reasoning. Bayesian reasoning handles uncertainty using probabilities. It updates the probability of an event based on new evidence. In our project, it calculates the probability of heart failure given a heart sound patterns, even if the sound is noisy. Then you have the point B, which is the probabilistic models. You have naive Bayes is a simple classifier that assumes features are independent. Bayesian networks model and dependencies between variables. In our project, we use naive Bayes to classify heart sounds as normal or abnormal, even with noise. Then you have the challenges of uncertainty. That is the point C. So, the point C, we can say that data is often noisy, incomplete, and ambiguous. Probabilistic models handle this by working with probabilities. In our project, the AI can still estimate heart failure risk even with missing or unclear data. The link to our project, the last 2 points, link to our project. According to our project uses probabilistic reasoning for prediction. We use models like naive Bayes to classify uncertain sound data. This uses naturalistic intelligence to interpret body signals. It acknowledges that not all medical knowledge can be certain. Then you have the module 7, which is planning. The first point is planning in AI. Planning in AI means creating a sequence of actions to achieve a goal. Each step includes defining the goal, choosing actions, and executing the plan. In our project, a plan for diagnosis might be record sound, processes, extract features, classify, and output diagnosis. Then we have the point B, which is goal-directed planning. For the goal-directed planning, you can the goal-directed planning. Planning is goal-directed. All actions aim for the desired outcome. The AI selects and sequences actions based on the goal. In our project, the goal is diagnosis. So the AI prioritizes actions that efficiently analyze heart sounds. Then we have the planning challenges and the link with our project. So the planning challenges, the frame problem is about choosing only relevant actions. The solution is to use data-driven insights. In our project, the AI uses heart sound patterns to guide its plan, focusing on magically relevant features. Then the link with our project plans a second from raw sounds to diagnosis. It uses frequent sound patterns to optimize the plan. This involves bodily kinesthetic intelligence for sequencing actions. It faces the frame problem, deciding which sound data is relevant. Then you have the module 8, which is planning and decision making. So the first point is planning and decision making. For the planning and decision making, AI combines planning with decision making. Planning sequences actions, decision making chooses actions based on utility and risk. In our project, the AI decides the best diagnosis method based on accuracy and speed. Then we have the point B, which is utility and risk. Utility measures the benefit of an action, like accuracy. Risk measures here the potential cost, like error. AI balances utility and risk to choose the best action. In our project, the AI picks a method that is accurate and safe. Then you have the decision-making challenges and the link with our project. So for the decision-making challenges, balancing utility and risk under constraints is challenging. The solution is data-driven optimization. In our project, the AI uses heart sounds features to make informed, safe decisions. Then you have the link to our project. This one, our project makes decision to choose the best prediction path. It uses associations, rules, and data patterns. This balance interpersonal intelligence, that is the passion trust, and intrapersonal intelligence, that is the self-reflection. It aligns with the simulation's arguments. AI simulates rational thought without consciousness. Then you have the module 9, that is the last module for the project, for our work, which is the machine learning. The first point is machine learning overview. So what to know here? Machine learning allows AI to learn from data. Supervised learning uses labeled data to predict, and the unsupervised learning finds hidden patterns without labels. So our project uses supervised learning to predict heart failure from labeled heart sounds. Then you have the point B, which is supervised versus unsupervised. The supervised learning does classification or regression. Unsupervised learning does clustering. That is the difference to know. In our project, we use supervised classification to label heart sounds as normal or abnormal. Then we have the point C, which is machine learning challenges. Challenges include noisy data and lack of labels. Solutions include cleaning data and combining supervised and unsupervised learning. In our project, we clean heart sounds and use clustering before classification and for better accuracy. Then for the last point, the link with our project. Our project uses machine learning, of course, to predict heart failure. Supervised learning classifies sounds, and supervised learning groups them. It uses logical, mathematical, and naturalistic intelligence. It raises the debate, can AI surpass human doctors in diagnosis? That is an interrogation. That is just a question for you, that we can answer and understand more about our project. So in conclusion, in synthesis, You can say that you covered, so far you covered 9 AI modules. Yeah, you have the history, problem solving, search, knowledge, inference, uncertainty, planning, decision making, and machine learning. Our project applies this to predict heart failure from sounds. It uses data, meaning multiple intelligences, and philosophical and science.